Hello. 10.1 we split into two parts. So 10.1a, we're saying how many ways you can choose from a group of objects where order doesn't matter, and we're distinguishing between permutations and combinations. So we have Mr. Smith's class, and they want to elect 3 class officers: president, vice president, and treasurer. We're not going to make it 5 candidates. It's 4 candidates are running for the offices. Adam, Bernie, Kara, and Dana. And how many ways can they be elected for these offices, and list all possible outcomes and stay organized. So the key is order matters, okay, because president, vice president, treasurer, if you get selected for president, that's different than being selected for vice president, right? So let's say president, vice president, and treasurer, it could be Adam, Bernie, and Kara, Adam, Bernie, and Dana, Adam, Kara, and Bernie, Adam, Kara, and Dana. Okay, I'm done saying their full names. Now we're just going A, B, C, D, okay? It could be A, D, B, A, D, C, okay? And so that's where the first person in the list or letter in the list is president, second is vice president, and third is treasurer. Okay, so that's all the ones where Adam's the president. We could also have where Bernie's the president, and so we have BAC, BAD, BCA, BCD. You're probably picking up the pattern. You're welcome to do it yourself and fast forward a little bit. And then BDA, BDC. And then if Kara is the president, CAB, CAD, CBA, CBD, CDA, CDB, almost. Now we have where Dana's the president, so DAB, DAC, DBA. It's really fun to listen to me say a bunch of letters, isn't it? DBC, DCA, DCB. Whew, okay. So then there's 24 different ways they can be elected. So those are all the ways, but if we wanted to just know how many, we could say we have 4 people. Sorry. We could just say we have 4 people. How many ways can we choose 3 of them, which is 4p3, which was 4 times 3 times 2, which was 24. So permutations, just like we did last chapter. Mr. Smith, wants to form a field trip committee from 3 of the above listed students. How many different committees are possible? For this one, order doesn't matter. So it doesn't matter if you get chosen first for the committee or last, you're still on the committee. Whereas for number 1, it was officers. So if you get president, that's different than being vice president or treasurer. So here, it's the same students and we're choosing 3 of them, but the order doesn't matter. So we have A, B, and C. We have A, B, and D, A, C, and D, or B, C, and D. And that's all the different ways. They could be in different orders, but it doesn't matter. So it's 4. So now let's talk about a combination, and then we will use that up above. So a combination is a group of R objects selected from a group of N objects where order doesn't matter. So the formula, NCR equals N factorial over R factorial times N minus R factorial. Okay? I'll tell you right now, there's no nice shortcut. Remember how for permutations you could do, like for 4p3 here, you could do 4 factorial over 4 minus 3 factorial. You could do 4 times 3 times 2. There's not like a fancy shortcut here. You just use the formula or put it in your calculator, or you make a list. So now back to number 2 here. Since order doesn't matter, we're having 4 and we're choosing 3 of them, but order doesn't matter. And so that ends up being our n is 4, so we have 4 factorial. Our r is 3 times 4 minus 3 factorial, which is 4 factorial over 3 factorial times 1 factorial. Okay? So this is 4 times 3 times 2 times 1 over 3 times 2 times 1 times another 1. So this is just 4, which is what we got making our list. This is also on your graphing calculator. It's menu probability combination, and then you enter it just like you would with, with permutation. So now it would be like NCR, you would do 4, 3, and that would also get you 4. Okay, you only get to use 2 of these 5 crayons out of red, orange, yellow, green, or blue to draw a picture, and we're going to list all the different color combinations. So for this one, order doesn't matter, okay? So you can use red and orange. You could use red and yellow, red and green, red and blue. You could use orange and red, but that's already covered. So orange and yellow, orange and green, orange and blue. You could use yellow and red, already did that. Yellow and orange, already did that. Yellow and green or yellow and blue. Or you could do, well, we already did blue and red, blue and orange, blue and yellow. So blue and green. Okay, so that's 4, 3, 2, 1. So 10 different combinations you can have. And as far as your calculator goes, well, it's 5 and you're choosing 2 of them, and order doesn't matter because you have 2 crayons in the end. It's not saying you have to use one more than the other, so it would be 5C2, which is 10. And if you were asked to write this with factorial, it would be n factorial, which is 10 factorial, over r factorial, 2 factorial, times 5 minus 2 factorial. So now we have a company with 12 employees. The boss picks 4 of them to go to California. How many ways can she do this? Well, basically, if order matters, that's a permutation. If order doesn't matter, it's a combination. And 4 of them get to go to California. We're just choosing them. It doesn't matter which order you're going in, who gets picked first. It's not that, some of them get to like fly first class to California. So it's just combination because it doesn't matter what order they're chosen in. So 12C4. And this is equal to 12 factorial over 4 factorial times 12 minus 4, which is 8 factorial. Put this in your calculator too, and you end up with 495 ways. From a group of 50 raffle tickets, how many ways can 3 prizes of $100 be awarded? Well, first of all, $100, like, great, we just know it's a prize. It doesn't matter to us, how much money the prize is. So we have a group of 50, so that's our N. And we're choosing 3 of them, so that's our R. And order doesn't matter because the prizes are all the same, right? They're all $100. I don't care if you get chosen first to get $100 or last to get $100. So order doesn't matter. So it's 50C3. That in your calculator is NCR 50, 50, 3, and you get 19,600 different ways. Okay, permutation versus combination. So permutation, use that when order matters. So this is when you are assigning jobs, titles, labels, or specific dollar amounts. I lost a U there, pretend that says amounts. So how many ways can you pick a president and a vice president from 6 people? That's 2 different titles. If the titles are different, if you're choosing different things to, I guess, differentiate between the people, among the people you're choosing, that would be 6 P2, which is 30. Combination, you use when order doesn't matter. The best way to think about this, or maybe the simplest, is you are in the group or out. So you're chosen or you're not. So how many ways can you choose a jury of 12 people from a group of 30? You're in the jury or you're not. It's not like you're the, foreman of the jury. I think that's what it's called. Or whatever. It's just you're in or out. So then it's 30C12, which according to your calculator is 86,493,225. Okay, so again, the main point of this lesson is to differentiate between permutations and combinations, and also be able to calculate them. So make sure you do the practice and the homework for today.